Another example, find two polar representations of the point. X is -1, y is +1. And we want to find one of them where r is positive and one of them where r is negative. So let's start this off. Maybe we can draw some axes here just to be able to get a little bit of reference, frame of reference going on. X is -1, y is +1. So we are over here. Let's bring back our conversion formulas. So we are going from rectangular to polar. So this tells us r should be the square root of -1 squared plus 1 squared. So that's 1 squared, 1 plus 1 is 2. So it's square root 2 here. And tangent theta is y over x. And so that is going to be 1 divided by -1, so -1. So we're thinking about when is tangent of theta equal to -1. Now, arctangent theta, arctangent of -1 is equal to minus pi over 4. But minus pi over 4 is in the wrong quadrant. So this angle right here is minus pi over 4. We want to instead go in this direction to get our normal angle. Maybe I should use usual angle there. That's corresponding to the r is greater than or equal to 0. So if instead we go this way, we end up with theta is going to be pi over 2 plus pi over 4. Theta is 3 pi over 4. A different way to see that is we're doing minus pi over 4 plus pi gives us 3 pi over 4. So that's corresponding to this, to our usual representation. So we have r is root 2 and theta is 3 pi over 4. So go 3 pi over 4, we point in that direction and walk root 2 units. But let's go back to this minus pi over 4 angle here. If this is our angle, we want to walk minus root 2 units in this direction. Walking minus root 2 units in this direction is while actually going in this direction. And so we can do that as minus root 2, comma, minus pi over 4. If instead you wanted to write 7 pi over 4 instead of minus pi over 4, that is completely okay as well. Or minus root 2 and 7 pi over 4. So here are two polar representations of this point. The usual one is with a positive r value. The other one has the negative of the corresponding r value, and the angle is off by pi radians.